Okay, in example 2b, we have an octagon, pretty familiar shape to us, with a radius of 9 feet. Now, we got to think about what that means. And again, I'm going to put in the central angle. So we have the center in here. So in this particular problem, the radius is right there. That's 9 feet. Both of those would be 9 feet. Still the same idea. We want to use our area equals 1/2 the apothem times the perimeter, but we've got a little bit different, given value here. But we're still going to go same directions. We're going to draw in the apothem, the perpendicular, right there. All right, and think of that central angle as we did before. This is 360 over n. This is an octagon, so that's an 8. So that comes out to be 45 degrees. Okay, now let's get one of those little right triangles again that will kind of flip up. Oops, sorry about that. Okay, got that. Now, what do we have in this? We know in this particular one, we know the hypotenuse is 9. We don't know the apothem. So that's over here. That's A. And also, we're going to need to find the base length so we can find the perimeter. So that x is actually half of one side, right? So once we get that, we will double that up to get a whole side. But we need both the a and the x in this picture. So we're going to use some trig. Now, remember, we got our central angle of 45 degrees. The upper vertex angle of this right triangle is going to be half of that. So this is going to be 22.5 degrees right there. All right. So we will use, let's first solve for the a value, and we'll say the sine of, well, down here would be 67.5. So that's just, subtracting. Those got to be complementary because of they got to add up to be 90 because of the other right angle in there, triangle sum theorem. So the sine of 67.5 equals opposite A over hypotenuse, which is 9. And if we solve for A right there, A is going to equal 9 times the sine of 67.5. So A is approximately 8.3. All right, so there's your apothem. Now we need that x value too. In order to figure out the perimeter, we got to know one of the side lengths of this thing. So if we can find x and double it, we can get that. So that is going to be the cosine of 67.5. And you could use 22.5 with some different, just switching it up. It doesn't matter. The cosine, the way I have it drawn of 67.5, is going to be adjacent over, so that's x over hypotenuse 9. And again, you're going to solve this to be x equals 9 times the cosine this time of 67.5. And x is going to be approximately 3.4. Now remember, x is half of a side. So one side is going to equal 2 times 3.4, which is 6.8 feet. And then the perimeter is going to equal 8 of those sides. So 8 times 6.8, which equals 54.4 feet. So now we can figure out our area of this octagon. Again, area is 1/2 the apothem times the perimeter. So our area is going to be 1/2. Our A value there is 8.3 and our our P value is 54.4. And this is going to come out in square feet, 225.8 square feet. So we have, kind of two pieces of trig there we needed to use with what was given, because we were given the radius. We used that. You look at that right triangle I drew. Put the right angle in here for you. Use that right angle, two pieces of trig. We used the sine of 67.5 to find the apothem. We used the cosine of 67.5 to find the x value, which is half the base. Doubled that to get the side length of 6.8 for each side of that octagon. Multiplied that by 8 to get the perimeter of that octagon. Use that with the apothem to find the area in the formula. Okay? And you'll be doing, these are great examples to help you through your homework. All right? Good luck.